students, welcome to the lecture on system analysis and design, and after this lecture we will be able to learn the following objectives: explain the concept of system analysis, define the elements of a system, discuss on system development life cycle SDLC, define rapid application development RAD, and understand the concept of prototyping. Let us discuss about system analysis and design. In business, system analysis and design refers to the process of examining a business situation with the intent of improving it through better procedures and methods. System analysis and design relates to shaping organization, improving performance, and achieving objectives for profitability and growth. The emphasis is on system in action, the relationship among subsystems and their contribution to meeting a common goal. Looking at a system and determining how adequately it functions, the changes to be made and the quality of the output are parts of system analysis. Organizations are complex systems that consist of interrelated and interlocking subsystems. Changes in one part of the system have both anticipated and unanticipated consequences in other parts of the system. The system approval is a way of thinking about the analysis and design of computer-based application. It provides a framework for visualizing the organizational and environmental factors that operate on a system. Now we are moving on to our next topic, that is concept of system analysis. The word system is widely used. It has become fashionable to attach the word system to add a contemporary flair when referring to things or processes. People speak of exercise system, investment system, delivery system, information system, education system, computer system, etc. System may be referred to any set of components which function in interrelated manner for a common cause or objective. The term system is derived from the Greek word system, which means an organized relationship among functioning units or components. A system exists because it is designed to achieve one or more objectives. We come into daily contact with the transportation system, the telephone system, the accounting system, the production system, and for over 2 decades, the computer system. Similarly, we talk of the business system and of the organization as a system consisting of interrelated departments, subsystems such as production, sales, personnel, and an information system. None of these subsystems is of much use as a single independent unit. When they are properly coordinated, however, the firm can function effectively and profitably. Organization implies structure and order. It is the arrangement of components that helps to achieve objectives. In the design of a business system, such an arrangement portrays a system-subsystem relationship, defines the authority structure, specifies the formal flow of communication, and formalizes the chain of command. Likewise, a computer system is designed around an input device, a central processing unit, an output device, and one or more storage units. When linked together, they work as a whole system for producing information. Interaction refers to the manner in which each component functions with other components of the system. In an organization, for example, purchasing must interact with production, advertising with sales, and payroll with personnel. In a computer system, the central processing unit must interact with the input device to solve a problem. In turn, the main memory holds programs and data that the arithmetic unit uses for computation. The interrelationship between these components enables the computer to perform. Interdependence means that parts of the organization or computer system depend on one another. They are coordinated and linked together according to a plan. One subsystem depends on the input of another subsystem for proper function. That is, the output of one subsystem is the required input for another subsystem. This interdependence is crucial in system work. An integrated information system is designed to serve the needs of authorized users, department heads, manager, etc. for quick access and retrieval via remote terminals. The interdependence between the personal subsystem and the organization user is obvious. Integration refers to the holism of system. Synthesis follows analysis to achieve the central objective of the organization. Interaction is concerned with how a system is tied together. It is more than sharing a physical part or location. It means that parts of the system work together within the system even though each part performs a unique function. Successful integration will typically produce a synergistic effect and greater total impact than if each component works separately. The last characteristic of a system is its central objective. Objectives may be real or stated. Although a stated objective may be the real objective, it is not uncommon for an organization to state one objective and operates to achieve another. This means that the analyst must work around such obstacle to identify the real objective of the proposed change. Let us discuss about elements of a system. In most cases, system analysts operate in a dynamic environment where change is a way of life. A major objective of a system is to produce an output that has value to its user. Whatever the nature of the output, goods, services or information, it must be in line with the expectation of the intended user. Inputs are the elements, material, human resources and information that enter the system for processing. Output is the output of processing. A system feeds on input to produce output in much the same way that a business brings in human, financial and material resources to produce goods and services. It is important to point out here that determining the output is the first step in specifying the nature, amount and regularity of the input needed to operate a system. For example, in system analysis, the first concern is to determine the user's requirements of a proposed computer system, that is, specification of the output that the computer is expected to provide for meeting user requirements. The processor is the element of a system that involves the actual transformation of input into output. It is the operational component of a system. Processor may modify the input totally or partially depending on the specification of the output. This means that as the output specification change, so does the processing. In some cases, input is also modified to enable the processor to handle the transformation. The control element guides the system. It is the decision-making subsystem that controls the pattern of activities governing input, processing and output in a computer system. The operating system and accompanying software influence the behavior of the system. Output specification determine what and how much input is needed to keep the system in balance. In system analysis, knowing the attitudes of the individual who controls the area for which a computer is being considered can make a difference between the success and failure of the installation. Management support is required for securing control and supporting the objective of the proposed change. Now let us discuss about System Development Life Cycle, SDLC. The SDLC System Development Life Cycle, just as the name implies, is defined as the process as a whole of developing system of software to meet certain requirements. It covers many activities, start from understanding why the system should be built, studying the project feasibility, analyzing problems, choosing the system design and architecture, implementing and testing it, up to delivering the system as product to the user. The SDLC is the process of gradual refinement, meaning that it is done through several development phases. Problem initiation includes define necessary input, output, storage, etc. Define what the problem really is. State a goal to be achieved. A problem initiation will describe required input, what data has to be acquired to produce the output, required output, that is, what information is the system supposed to produce. Problem analysis breaks the problem down into the parts and describes them. Note that this step does not care what solution will be used to solve the problem. The analysis lays down the basic requirements that the eventual solution must achieve: logical design. During problem Initiation, one of the first things to do is to define the problem correctly. If we get this wrong or skip it completely, everything we do afterwards could be a complete waste of time and money. The most important task in creating a software product is extracting the requirements. Customers typically know what they want, but not what software should do. While incomplete, ambiguous or contradictory requirements are recognized by skilled and experienced software engineers. Frequently, demonstrating live code may help reduce the risk that the requirements are incorrect. In practice, most successful specifications are written to understand and fine-tune applications that were already well developed, although safety-critical software systems are often carefully specified prior to application development. Specifications are most important for external interfaces that must remain stable.
Let's first touch on the Systems Development Lifecycle, also known as the SDLC. The SDLC is a traditional methodology used to develop, maintain, and replace information systems. It consists of 5 phases. These are planning, analysis, design, implementation, and maintenance.
The first phase to the SDLC is planning. Planning is an organization's total information systems needs are identified, analyzed, prioritized, and arranged. This is where project management begins. You take the input, you do investigations and initiations at the highest level, and create system concepts development. It's also where we're going to use the tool Gantt chart from Microsoft Project for scheduling. Analysis is the second phase of the SDLC. In analysis, system requirements are studied and structured. We gather system requirements, use documentation, and understand our scope, constraints, risks, and cost. The tools used during analysis are DFD diagrams, WBS, meaning work breakdown structure, and BRDs. The third step to the SDLC is design. Design is a description of the recommended solution and is converted into logical, then physical system specifications. There are 2 steps to the design process. There's the logical and the physical design. The logical contains the process view, meaning UML diagrams and activity diagrams. In the data view, or the physical design, we're going to use ERD diagrams, communication sequences, and dimensional models.
The most common misused tools are the UML, activity diagrams, and ERDs. UML, standing for Unified Modeling Language, are a type of modeling language in the field of standardized object-oriented software design. Activity diagrams are graphical representations of workflows, activities, and actions. Activity diagrams can be used to describe the business and operational step-by-step workflows of components in a system. It essentially shows the overall flow of control. ERD, or Entity Relationship Diagrams, are a notational way to describe entities, relationships, and attributes in a database.
The next phase to the SDLC is implementation. In implementation, the information system is coded, tested, installed, and supported in the organization. This can include executing, coding, constructing the system, testing, and installing. Maintenance is the last step to the SDLC. In maintenance, an information system is systematically repaired and improved. This can include maintaining the system, supporting, training, updating and improving, and then also repairing the system. Next, we're going to talk about the methodologies used in systems analysis and design. Methodologies are used to execute a process. Examples include Waterfall, case tools, rapid application development, Agile Methodologies, and extreme programming.
The Waterfall Approach is where one phase begins when another completes, with little backtracking or looping. The pros of this give a high level of control to the developer. On the downside, this gives increased time for development, and system requirements are locked in and cannot be changed. Computer-aided software engineering tools, also known as case tools, will debug your diagrams and generate code based on them. They can assume some roles as programmers. On the positive side, this displays a good look and feel, gives great graphical representations of the system, and keeps everything in a central repository. On the downside, it's very difficult to use with existing systems. Rapid Application Development, also known as RAD, is a methodology to radically reduce design and implementation time using extensive user involvement prototyping and integrated case tools. The pros of this are that it decreases the design and implementation time. On the downside, it is a very high-cost approach, and it's only meant to be used for large projects, so it's really not useful for smaller systems. Agile methodologies are motivated by recognition of software development as fluid, unpredictable, and dynamic. The pros of this approach are that they are adaptive and flexible. The downside is that it requires heavy customer interaction and extreme programming skills. Lastly, extreme programming consists of short incremental development cycles and automated tests. On the plus side, this maintains a constant stream of communication with the developers. It is also a very fast approach. On the downside, it requires a lot of communication with developers who are not necessarily good at communicating with individuals who are not technical.
For our team's approach, we plan on using the structure of the SDLC lifecycle.
Here are some possible definitions of problems. The existing system has a poor response time, that is, it is slow, it is unable to handle workload. The problem of cost, that is, the existing system is not economical. The problem of accuracy and reliability. The requisite information is not produced by the existing system. The problem of security. Similarly, a system analyst should provide a rough estimate of the costs involved for the system development. This is again a very important question that too often is not asked until it is quite late in the system development process. The lateral meaning of feasibility is vitality. The study is undertaken to know the likelihood of the system being utilized in the organization. Feasibility study basically is a high-level capsule version of the entire process intended to answer a number of questions like what is the problem? Is the problem even worth solving? However, as the name indicates, in preliminary investigation, feasibility study should be relatively briefed, as the objective at this stage is not only to get an idea of the scope. The findings of this study should be formally presented to the user management. This presentation marks a crucial decision point in the life of the project. If the management approves the project, the feasibility study report represents an excellent model of the system analysis, understanding of the problem, and provides a clear sense of direction for the subsequent development of the system. The aim of the feasibility study is to assess alternative system and to propose the most feasible and desirable system for development. Thus, feasibility study provides an overview of the problem and acts as an important checkpoint that should be completed before committing more resources. The feasibility of a proposed system can be assessed in terms of four major categories as summarized. Organizational feasibility, the extent to which a proposed information system supports the objective of the organization. Strategic plan for information system determines the organizational feasibility of the system project. The information system must be taken as a subset of the whole organization. Economic feasibility. In this study, costs and returns are evaluated to know whether returns justify the investment in the system project. The economic questions raised by the analysis during the preliminary investigation are for the purpose of estimating the following: the cost of conducting a full system investigation, the cost of hardware and software for the class of application being considered, the benefits in the form of reduced cost, improved customer service, improved resource utilization, or fewer costly errors. Technical feasibility. Whether reliable hardware and software capable or meeting the needs of the proposed system can be acquired or developed by the organization in the required time is a major concern of the technical feasibility. Operational feasibility. The willingness and the ability of the management, employees, customers, suppliers, etc. to operate, use and support a proposed system come under operational feasibility. Primary objective of analysis phase is to understand the user's needs and develop requirement for software development. It involves activities like gathering information, define software requirement, prioritize requirement, generate and evaluate alternatives, require recommendation with management. Before we start trying to solve a problem, it's important to study the existing system before embarking on major changes. A data flow diagram is used to describe the flow of data through a complete data processing system. Different graphic symbols represent the clerical operation involved and the different input storage and output equipment required. In short, it is a schedule of software development life cycle. Structure chart consists of a top-down description of a process and its sub-processes. The code generation step performs this task. If the design is performed in a detailed manner, code generation can be accomplished without much complication. Programming tools like compilers, interpreters, debuggers, etc. are used to generate the code. Software testing is the process of checking software to verify that it satisfies its requirements and to detect errors. Software testing is an empirical investigation conducted to provide stakeholders with information about the quality of the product or service under test, with respect to the context in which it is intended to operate. Testing can never completely establish the correctness of computer software. A primary purpose for testing is to detect software failures so that defects may be uncovered and corrected. Testing methods. Software testing methods are traditionally divided into black box testing and white box testing. These two approaches are used to describe the point of view that a test engineer takes when designing test cases. Black box testing. Black box testing treats the software as a black box without any understanding of internal behavior. It aims to test the functionality according to the requirements. Thus, the tester inputs data and only sees the output from the test object. While box testing, however, is when the tester has access to the internal data, structures and algorithm, and the code that implement these. The following types of white box testing exist. Code coverage. Creating tests to satisfy some criteria of code coverage. Mutation testing methods, fault injection methods, static testing. White box testing includes all static testing. In SDLC, implementation refers to post-development process of guiding a client to use a software or hardware that was purchased. This includes requirements analysis, scope analysis, customization, system integration, user policies, user training, and delivery. Analysts in the implementation phase acts as the intermediate between user and developers. The implementation phase includes hardware and software installation, user training, documentation. Primary objective of implementation phase are to ensure that software is installed, the system are placed and used by actual users, the users are all trained, training is provided to the user of the system usually through workshops or online. The business is benefiting. Software will definitely undergo change once it is delivered to the customer. There are many reasons for the change. Change could happen because of some unexpected input values into the system. In addition, the changes in the system could directly affect the software operation. Maintenance includes activities like keeping the system up to date with the changes in the organization and ensuring it meets the goals of the organization by building a help desk to support the system user, implementing changes to the system when necessary. System maintenance involves the monitoring, evaluating and modifying of a system to make desirable or necessary improvements. In other words, maintenance includes enhancement, modification or any change from the original specification. Software needs to be maintained not because some of its modules or programs wear out and need to be replaced, but because there are often some residual errors remaining in the system which have to be removed as soon as they are being discovered. The phases in the Rapid Application Development RAD model are business modeling. The information flow is identified between various business functions. Data modeling. Information gathered from business modeling is used to define data objects that are needed for the business. Process modeling. Data processed, defined and data modeling are converted to achieve the business information flow to achieve some specific business objective. Application generation. Automated tools are used to convert process models into code and the actual system. Testing and turnover. Test new components and all the interfaces. The advantages of the RAD model are reduced development time, increases reusability of components, quick initial reviews occur, encourages customer feedback, integration from very beginning solves a lot of integration issues. The disadvantages of RAD model depends on strong team and individual performance for identifying business requirement. Only a system that can be modularized can be built using RAD. Requires highly skilled developers, designer, high dependency on modeling skill. In appliance to cheaper project as cost of modeling and automated code generated is very high. RAD should be used when there is a need to create a system that can be modularized in 2 to 3 months of time. It should be used if there's high availability of designers for modeling and the budget is high enough to afford their cost along with the cost of automated code generating tools. The RAD SDLC model should be chosen only if resources with high business knowledge are available and there is a need to produce a system in a short span of time, 2 to 3 months.
Rapid application development.
Rapid application development is a software development methodology that uses minimal planning in favor of rapid prototyping. The planning of software developed using RAD is interleaved with writing the software itself. The lack of extensive pre-planning generally allows software to be written much faster, and makes it easier to change requirements.
History.
Rapid application development RAD is a term originally used to describe a software development process first developed and successfully deployed during the mid-1970s by the New York Telephone Co. Systems Development Center under the direction of Dan Gillen. Following a series of remarkably successful implementations of this process, Gillen lectured extensively in various forums on the methodology, practice, and benefits of this process. RAD involves iterative development and the construction of prototypes. In 1990, in his book RAD, Rapid Application Development, James Martin documented his interpretation of the methodology. More recently, the term and its acronym have come to be used in a broader, general sense that encompasses a variety of methods aimed at speeding application development, such as the use of software frameworks of varied types, such as web application frameworks. Rapid application development was a response to processes developed in the 1970s and 1980s, such as the structured systems analysis and design method and other waterfall models. One problem with previous methodologies was that applications took so long to build that requirements had changed before the system was complete, resulting in inadequate or even unusable systems. Another problem was the assumption that a methodical requirements analysis phase alone would identify all the critical requirements. Ample evidence attests to the fact that this is seldom the case, even for projects with highly experienced professionals at all levels. Starting with the ideas of Brian Gallagher, Alex Balkin, Barry Boehm and Scott Schultz, James Martin developed the rapid application development approach during the 1980s at IBM and finally formalized it by publishing a book in 1991, Rapid Application Development.
4 phases of RAD.
Requirements planning phase combines elements of the system planning and systems analysis phases of the system development life cycle SDLC. Users, managers, and IT staff members discuss and agree on business needs, project scope, constraints, and system requirements. It ends when the team agrees on the key issues and obtains management authorization to continue. User design phase. During this phase, users interact with systems analysts and develop models and prototypes that represent all system processes, inputs, and outputs. The RAD groups or subgroups typically use a combination of joint application development (JAD) techniques and case tools to translate user needs into working models. User design is a continuous interactive process that allows users to understand, modify, and eventually approve a working model of the system that meets their needs. Construction phase focuses on program and application development tasks similar to the SDLC. In RAD, however, users continue to participate and can still suggest changes or improvements as actual screens or reports are developed. Its tasks are programming and application development, coding, unit integration and system testing. Cutover phase resembles the final tasks in the SDLC implementation phase, including data conversion, testing, changeover to the new system, and user training. Compared with traditional methods, the entire process is compressed. As a result, the new system is built, delivered, and placed in operation much sooner.
Relative effectiveness.
The shift from traditional session-based client-server development to open sessionless and collaborative development like Web 2.0 has increased the need for faster iterations through the phases of the software development process. This, coupled with the growing use of open-source frameworks and products in core commercial development, has, for many developers, rekindled interest in finding a silver bullet RAD methodology. Although most RAD methodologies foster software reuse, small team structure and distributed system development, most RAD practitioners recognize that, ultimately, no one rapid methodology can provide an order of magnitude improvement over any other development methodology. All types of RAD have the potential for providing a good framework for faster product development with improved software quality, but successful implementation and benefits often hinge on project type, schedule, software release cycle and corporate culture. It may also be of interest that some of the largest software vendors such as Microsoft and IBM do not extensively use RAD in the development of their flagship products, and for the most part, they still rely primarily on traditional waterfall methodologies with some degree of spiraling. This table contains a high-level summary of some of approaches that can be thought to have their roots in RAD.
Criticism.
Since rapid application development is an iterative and incremental process, it can lead to a succession of prototypes that never culminate in a satisfactory production application. Such failures may be avoided if the application development tools are robust, flexible, and put to proper use. This is addressed in methods such as the 2080 development method or other post-Agile variants. Furthermore, there is a phenomenon behind a failed succession of unsatisfactory prototypes. End users intuitively and primarily look to the graphical user interface GUI as a first measure of software qualities. The faster they see something working, the more rapid they perceive the development cycle to be. This is because the GUI has a strong natural directly viewable presence, while other problem domain code must be deduced or inferred, going largely unnoticed. As programmers are generally software end users first and programmers later, this natural gravitation towards seeing is ingrained from the beginning. For example, Hello World is not about the data or business domain, but is about seeing something on a screen. Programmers without clear training towards understanding this deceptive quality of software also tend to gravitate their measurement of rapid in RAD by how quickly the GUI progresses. The tendency is further strengthened by the fact that end users hold the financial reward programmers seek, leading them to ignorantly cater to the measurement mindset of the end user rather than a suitable and more realistic alternative. Consequently, many software development tools strongly and primarily focus on the application GUI as well. This tendency to measure rapid by means of the GUI is strengthened further by programmers who in turn become RAD tool producers. They also have a strong financial interest and cater to the software development community GUI-centric model. Finally, an anecdotal review of RAD tools reveals the strong GUI focus, where Hello World and other GUI-centric examples abound and a dearth of data or business problem domain examples exist. Ultimately, the triad of players, for example end users, programmers, tool developers, each with a strong and misplaced focus on the GUI aspects of software applications, leads to a cultural underemphasis of the bulk of what the software text is actually about, the business and data problem domains. Furthermore, The culture of RAD and indeed of software in general, with the central GUI emphasis, presents a multifaceted problem for engineers who recognize the problem and seek to overcome and engender an opposite environment and users, developers and tools. First, there is the lack of rapid application development tools that emphasize the appropriate problem domain. Next, appropriately trained engineers have the task of training and educating end users to see the counterintuitive data and business code as the appropriate measure of how well or rapidly a software product is being developed. Finally, there is a lack of project engineers who understand the misplaced problem domain and are trainable and capable to the task of reorienting themselves to the counterintuitive viewpoint.
Practical implications.
When organizations adopt rapid development methodologies, care must be taken to avoid role and responsibility confusion and communication breakdown within a development team, and between team and client. In addition, especially in cases where the client is absent or not able to participate with authority in the development process, the system analyst should be endowed with this authority on behalf of the client to ensure appropriate prioritization of non-functional requirements.
Prototyping. The objective and the plans are laid by the customer and the analysis developer. They identify the requirements for making the system more feasible. The user and the developer identify the data which will be needed for the system. They also predict the output that the system will yield. The user actually works on the prototypes in order to evaluate its operations and features. In this phase, a feedback from the user side is obtained from users and the required suggestion, if any, are made by the users. Summary. Now in the end, let us summarize what we have learned in this lecture. In business, system analysis and design refers to the process of examining a business situation with the intent of improving. Interaction refers to the manner in which each component functions with other components of the system. The SDLC system development life cycle, just as the name implies. The RAD model is Rapid Application Development Model. It is a type of incremental model. The SDLC is a process of gradual refinement, meaning that it is done through several development phases.